So in this lecture, we are going to discuss the dimensional analysis. So which are the basic dimensions? The basic dimensions are mass, length, and time. So these are the basic dimensions, and we write it as in short form MLT. So if our dimension is single, then we write M1, L1, T1. Means M raised to power 1, L raised to power 1. So we can extract the quantity into this basic dimension, mass, length, and time. And just we will see an example so that our concept will get clear. Okay. Such as if you consider the force, the formula for force according to the second law, Newton's second law, is mass into acceleration. Okay. So now how we can write the dimension for this mass? You can write it as M1, capital M1 is the dimension for your mass. For acceleration, what you can write? The again formula for acceleration is velocity divided by time, right? Rate of change of velocity is the acceleration. Again, the velocity will have a certain formula. What is the formula for velocity again? Rate of change of displacement is the velocity, right? So we will write it here, the displacement, that is S divided by T. So this T into T will be T square. Okay. Now again, your S is there. S is the displacement. Now this is the basic thing. And the dimension for displacement is L1 because it is the one time of the length, right? So we can, for displacement, we can write L1, and for T square, we can write capital T raised to power 2. Okay. So the dimension for your acceleration is L1 divided by T square. Okay. Now we will extract it here. The dimension for mass is M raised to power 1. This is our first quantity. Our second quantity is acceleration. And again, the unit for this acceleration, unit means the dimension for this acceleration, we can write it as L1 multiplied by T raised to power minus 2, because here L1 divided by T square is there. So when this T square will go to the numerator, we can write it as T raised to power minus 2. Okay. So L1 multiplied by T raised to power minus 2. Now again, we multiply the square brackets and we can extract it here, and finally we will get M1 L1 T raised to power minus 2. So this is what the basic dimensions for your force. Now if anyone asks you regarding the dimension of the quantity force, then definitely you can say M1 L1 T raised to power minus 2 are the basic dimensions for your quantity force. And this force quantity will be very much useful to you whenever you are going to solve any numerical based on the dimensional analysis. So as we are learning the fluid mechanics, so that's why this force quantity is important to us. Now, there is one more quantity in fluid mechanics, and that is your surface tension. Okay, so what is the definition of surface tension? Because whenever you have any quantity, you should be able to know its formula. Okay, if you don't know the formula, then you will not be able to find the exact dimension. So the formula for surface tension is force divided by the length. Means what? Surface tension is force per unit length. Okay, so now we know the dimensions for the force. The dimensions for force are m1 L1 T raised to power minus 2. So we will write it here. M1 L1 T raised to power minus 2. Divided by length. So the dimension for your length will be again L1. Now we can arrange these two dimensions. L1 is in denominator. Okay, and L1 is also present in numerator. So that's why this L1 will get cancelled, and finally you will get M1 L raised to power 0, because your L gets cancelled, so therefore L raised to power 0, and T raised to power minus 2. So now this is the basic dimension for your surface tension. Okay, so I hope that you got it. There are various quantities out of which you can extract that quantities into the basic dimensions. Such as, we are having one more quantity, that is the torque. Now, the formula for torque is force multiplied by the distance, right? Now, how we can find the dimensions for this torque? Force multiplied by distance. It gives you the quantity at which force the object is rotated or the shaft is rotated, and that quantity is nothing but torque, force multiplied by distance. You know the basic dimension of the force, that is M1 L1 T raised to power minus 2. So you know the basic dimension for your force. After that, you also know the basic dimension of distance, and the basic dimension of distance is L1 you can have the multiplication of this L1 into L1. The powers get added, and finally you will get M1 L1 L1 multiplied by L1 will give you L raised to power 2 and T raised to power minus 2. Okay. So M1 L2 t raised to power minus 2. After that, there is one more quantity, and that is the pressure, right? In fluid mechanics also, we have this quantity, that is the pressure. So how you can find the pressure? The formula for pressure is again force per unit area. Force per unit area is the pressure. Pressure exerted on the object. Okay. So the basic dimension for your force is M1, L1 and t raised to power minus 2. Okay. So this is the, what you can say, basic dimension for your force divided by area. The dimension for your area is L raised to power 2, right? Because length multiplied by length will give you the L square. Right? Now after that, you can further solve it. L2 will go to the numerator. L1 minus 2 will give you L raised to power minus 1. Right? And finally, we can write it as M raised to power 1, L raised to power minus 1, and T raised to power minus 2. So the same dimensions will also be for your stress, because the formula for stress is again force divided by the area. Only the thing is that stress comes from the inside, while as pressure is exerted from the outside. That is the only difference. But the formula is same, that is force per unit area. After that, there is one more quantity, and that quantity is strain. So how you can find the dimensions for the strain? What is the strain? In Newton's law of viscosity, you are having the rate of shear strain, right? So rate of shear strain, you are having that quantity. What is been my strain? Strain is change in length divided by original length. That is your change in dimension divided by the original dimension. That is delta L divided by capital L. Change in length divided by original length. Now what is the dimension for length? L1 will have same dimensions for the change in length. So L1 divided by L1 will give you M0, L0 and T raised to power 0. Right? Because L1 will get cancelled. Now all the three basic dimensions are having raised to power 0. So what is the meaning of this? The meaning of this is this quantity is what we can say that dimensionless quantity. Dimensionless quantity. Okay. So this strain, we called it as dimensionless quantity. It doesn't have the dimension. Okay. Now, which are the such type of quantities which don't have the dimension? Such as In physics, we call it as a refractive index. It is the ratio of two velocities. Again, it is a dimensionless quantity, right? So there are also more number of dimensionless quantities, such as the Poisson's ratio is there. When we have the Poisson's ratio, the Poisson's ratio is the ratio of two similar quantities, that is lateral strain upon longitudinal strain. And that's why Poisson's ratio also doesn't have the dimension. Okay, so I hope that you got it. What are the various dimensionless numbers, right? Then various numbers such as the what you can say, various other numbers are also, these other quantities are also there which don't have the dimension. You need to find it. Okay. Now after that, one more quantity is there, and that is the energy. Now, what is meant by this energy? Energy is what you can say, your capacity to perform the work or capacity to do the work is your energy, right? Capacity to do the work is your energy. And the formula for energy is same as that of the formula for work done. The formula for your energy is what you can say, the formula for your energy is force multiplied by the distance. Now this same formula is there for your work done also, right? Now we know the dimension of force, that is m1 L1 t raised to power minus 2, right? Multiplied by distance. So distance will have the dimension L1, right? So at final you will get M1 L1 L1 into L1, that is the L raised to power 2, and at final you will have t raised to power minus 2. Now the same dimensions will be there for your work done, because both are having the same formula, that is your force multiplied by distance. Okay. So in such a way you can find out the various basic dimensions. Now, are there any other conditions beyond this MLT, that is the mass, length, and time? Yes, there are other dimensions also, such as, now I will point it out the other dimensions, such as the current is there. Current we measure in what you can say ampere, right? Current we measure for current we can use it as a capital A, and for temperature we can use it as a theta. Okay, such as your formula for current I is equal to charge divided by time, right? So therefore charge is equal to current multiplied by time, right? So suppose that this charge is Q is equal to I multiplied by T, that is current multiplied by time. So the dimension for current is ampere, that is your A1, and dimension for your time is T1, right? So maybe in any competitive exam, you may get such question. That is, what are the other dimensions also? For current, you are having the ampere. For temperature, you are having the theta. Okay, so these are the things. Now after that, you can have the various other quantities also, such as in while seeing the example for your temperature, we can have the basic formula. In physics, you are having the basic formula, that is PV is equal to nRT, right? This formula you learned. Now this N into R can be taken as a constant, and that constant can be a capital K. So your capital K is equal to PV divided by T, right? PV divided by, and T will be your temperature, right? So for temperature, you will have the T raised to power 1. So T and your time will get coincide, right? So that's why for temperature, we write it as a theta raised to power 1. So you'll have the dimension for your pressure. So dimension for your pressure, you are having this dimension for your pressure here. Already we have imported it. M1 L raised to power minus 1 T raised to power minus 2, right? For volume, we will have the L raised to power 3, that is L cube, right? So for pressure, we can write it as M1 L raised to power minus 1 T raised to power minus 2 multiplied by L cube, because the volume is there, right? So therefore L cube divided by theta raised to power 1, right? So what will be the final dimensions? M1 L raised to power minus 1 minus 1 plus 3, you will have the minus 2. 3 minus 1, you will have the plus 2. Okay. And T raised to power minus 2 multiplied by theta raised to power minus 1, right? Because theta is in denominator, it will come to the numerator. Okay. So I hope that you got it. This type of other dimensions are also present. Now there is one more formula for your gravitational constant, right? That is the universal gravitational constant, not our acceleration due to gravity. F is equal to capital G m1 m2 divided by d square, right? So we have that law that every body in the universe attracts the other body, right? And that force is directly proportional to the product of their mass and inversely proportional to the square of their distance, right? So according to this law, we have this law of gravitation, we have this formula F is equal to G m1 m2 divided by d square, and G is nothing but your universal gravitational constant, right? So for G also, we can find it out the dimension, such as G is equal to F into d square, F into d square divided by m1 into m2, right? That are the two masses of the bodies. So we know the dimensions for F, that is m1 L1 T raised to power minus 2, right? And for d square, we are having the L square as a dimension divided by m1 m2, that is capital M raised to power 1, capital M raised to power 1, that is M raised to power 1. And further we can solve it as, again, M raised to power minus 1, because this 2 will come to the numerator. L raised to power 3, because 1 plus 2, that is 3. And T raised to power minus 2, right? So This is the basic dimensions for your gravitational constant. Now, after that, you are having the various what you can say quantities such as the angular velocity omega is there. What is the formula for omega? Angular velocity? Velocity divided by the radius of the circle. This angular velocity is for the angular motion, for circular motion, for curvilinear motion, for rotational motion. We are having this formula, right? So you know the dimensions for velocity, that is displacement L1 divided by time, that is -1. So L1t minus 1 for the velocity. So for radius, you are again having the L1, right? So your L1 will get cancelled, and finally you will have the t raised to power -1, right? For the same unit will be for your frequency also, right? So frequency will also have the same dimension. Right? Now, one more quantity you may have, that is the what you can say angular momentum, right? So the angular momentum, you are having the formula mv into r, right? So again, you will have the dimension for mass will be your m1. Dimension for velocity, you have L1 t raised to power -1. And dimension for radius is again your L1, right? So L1 into L1, you will have the L raised to power 2. So this will be the dimensions for your angular momentum. So in this way, you have all these dimensions. You can solve the various numericals based on this dimension. Various questions can be asked in your examination based on this dimensional analysis, right? So this is all about the basic dimensions. Now in our next lecture, we will see the dimensional analysis and the numericals based on the dimensional analysis.